Hello, my name is Dshawn Grigsby. I'm with the Dell Prentice Company and we represent Pentair Thermal Management Heating Solutions. Congratulations on your new purchase. In this training session, we'll cover self-regulating cable, what is it and how does it work. We'll then go over the components that's at your facility site. Then we'll talk about the controller and we'll dive deep into that as far as programming, the features, and also how to clear alarms. And then finally, we'll go over any safety procedures that you should adhere to when activating the system. Generally, there are two different types of heat trace. One is mineral insulated heat trace, which is MI cable, which is a constant wattage heating cable. It simply means that when you energize the cable, it will remain that wattage. Let's say, for instance, you have a 20-watt cable. It will remain 20 watts as soon as you energize it until it's de-energized. Now, because of this, you can't touch or cross the cables. If you do, it'll continue to burn at 20 degrees or 20 watts per foot. And eventually, the cable will fail. On the other hand, self-regulating cable is, as this name applies as well, it regulates up and down depending on the ambient temperature surrounding the actual cable. I have a brief video that I want to show you. It's just over a minute long and it explains to you exactly what self-regulating cable is and how it works. And I'll see you after the video.
Raychem self-regulating heating cables automatically adjust their power output to compensate for temperature changes. The outer jacket, braid, and inner jacket provide mechanical, chemical, and electrical protection. But the magic happens in the conductive core that surrounds the two parallel conductors. As the ambient temperature drops, the core contracts microscopically, and the number of electrical paths through the core increases. More heat is produced. Conversely, as the ambient temperature rises, the core expands and has fewer electrical paths. Less heat is produced. At a certain temperature, almost all electrical paths are disrupted and power output is close to zero. A self-regulating heating cable adjusts its power output along its entire length. That's what makes it a safe and reliable solution for many applications.
What you just saw in the video is that self-regulating cable has two bus wires. It has a core in the middle with electrical links in between. Now, those electrical links has molecules that can expand and contract as the temperature changes. Let's say, for instance, for example, you threw a party. You invited a lot of guests and they're all confined to one room. Well, if the room is real cold, a lot of your guests may huddle together in order to generate more heat. On the other side, if the room gets too warm, they may separate to reduce the heat. Essentially, that's what self-regulating cable do. Now, say for instance, you have a 5-watt heating cable. It's supposed to heat at 5 watts at 50 degrees Fahrenheit. Now, if it goes above 50 degrees Fahrenheit, then the output of the heating cable will be less. Say for instance, maybe 4.5 watts per foot. On the other hand, if it gets cold, say for instance 40 degrees Fahrenheit, then your heating output may go up to like maybe 5.5 watts per foot. So let me ask you a question. This is quiz number 1. Can self-regulating cable touch or cross itself? Well, if you answered yes it can, you're absolutely correct. And the reason for this is, if that heating cable touches or crosses, if it gets too warm, it'll regulate itself down. So that's self-regulating heating cable in a nutshell. Now we're going to look at the components involved with the heat trace cable on your site. First of all, you have two circuits coming out of an electrical distribution panel. Then that goes into this 910 controller. We'll talk about this a little bit more in detail a little later. Out of the 910 controller, you also have a sensor, which is an RTD. There are two types of RTDs. One is an ambient sensing that senses the air temperature, and then the second is like this right here, which is a line sensing RTD, which goes on the actual pipe itself. But you connect it to the terminals in here, and we'll discuss that a little later. Out of the 910 controller, you have electrical wires like THHN going into two of the JBS 100As, and this is a power connection kit. Anytime you have heat trace, you have to have a transition, and this serves as the transition. Now the JBS 100A is a class 1 Div 2 rating on it, and when you open it, as I'm about to, you have your incoming wires. By the way, this is off, and anytime you want to deal with electricity, of course, you turn the breaker off. You have your three wires. You have one ground, and you have your two hot legs, or in this case, since this is 120 volt, you have your neutral and your ground. Then, on the other side, you have a transition into the heat trace. Now, this is your ground braid here from your heat trace, and then these are your two bus wires. These go to your two bus wires. You need a transitional piece, which is a core seal. So this is what this is right here, and essentially it helps for two reasons. One is moisture, and the second is so this doesn't ground fault. Because if these wires weren't here, or this core seal wasn't here, this would probably show up if you tested it as a bad heat trace cable, or it could show up as a ground fault. So this is what you have on site here. Now the heat trace comes out of this box onto the pipe. Now this demo is a little incorrect because usually you'll have the heat trace at either 4 or 6 o'clock on the pipe itself. Also, you mount the heat trace with either glass tape if you're using steel, and the glass tape comes in two different types. One is a GT66 and one is a GS54. If you're using this on PVC or fiberglass pipe or stainless steel, you want to use an aluminum tape that goes across the heat trace, and it attaches the heat trace to the actual pipe. Another inconsistency with this particular diagram that wouldn't be out in the field is this label right here. This is a warning label showing everyone that heat traces below the insulation. So this label would actually go above the insulation after the heat trace is installed. And always at the end of the circuit, you have an end seal. Now this particular end seal, you can either have a lighted end seal like this one, or you can have an unlighted end seal. It really doesn't make a difference. It's just personal preference to the customer. But sometimes it does look good to see that the heat trace is on just by looking up at it. And essentially, these are your components for your system. Now I think it's a good time to go over a brief overview of what you have on site. First of all, you have two 910 controllers that's mounted on the wall. You have conduit going up the wall and out of the building. Then starts your power connection kit, which is your JBS 100A. The heat traces ran over the trestle and insulated, and it has a warning label on top of it. And on the end of your run, you have two end seals, one on each pipe. And essentially, that's a brief overview of your system. Now we're going to take a look at the features of the 910 controller. We're going to learn how to change the set points and also how to clear any alarms that may occur during its activation. Okay, now we're going to talk about the different features for the 910 controller. As you can see, I have opened the cover, And I also removed the safety cover inside here to expose the inner parts here. We have the terminal blocks here, which connects the RTD, like I talked about before. We also have, we also have the blocks for the incoming power and also the outgoing power. Now, like I said before, this is de-energized. If this was energized, I wouldn't be opening this up, for one. And two, you would have a running display on the actual circuit board here. So you have your incoming power here, your outgoing power to your heat trace, and then your RTD. And essentially that's all of the components that's inside and how that works. Now you also have a feature for an alarm. That's not hooked up right here because it's a demo version, but you can hook this up as alarm back to the BMS or building management system, or a dry contact alarm as well. Now let's go on to the features. This 910 controller is actually rated for 120 volts up to 277 volts and anywhere in between. So a lot of times people look at the literature and see 277 volts. Well, that's the maximum voltage that this could take, and anywhere in between, like I said before. Also, this is equipped with ground fault protection. The electrical code mandates back in 1990s that heat trace must be ground fault protected, and this has an equipment ground fault protection up to 30 amps or 30 milliamps. Also, another feature on this particular controller is it's geared for monitoring. It monitors temperature, it monitors voltage, resistance, ground fault, as I said before, and also wattage as well. You have the ability, and I'll show you a little bit later, to change the set points and different functions in the heat trace controller. And also another feature, the last one I'll talk about right now, is it has a proportional or deadband function on it. What that means is the deadband function is, say for instance this is 40 degrees of a set point of 40 degrees. Well, if you have a 5-degree deadband, it won't shut off for 5 degrees above and below. So 35 or 45 degrees. So that's important. But if you want a more accurate reading, we have a proportional control. Proportional control essentially shuts the heat trace on and off because this has a solid state relay, and you can do this pretty much indefinitely. It could shut itself off and on and save you at least half of your electrical bill. So both of those features work, and they're great, and this controller has it. Now we'll discuss the actual programming of the controller. Alrighty, now let's look at the programming of the 910 controller. I'm not sure if you'll be able to read these buttons, but you have 4 buttons up top here, which is shift, test, back, and enter. Above the test button is the alarm word. Above the back button is the monitor, and above enter is configure. Anytime you want to access the system, you always have to hit the shift button first. When you hit the shift button, that light will appear right above it. Now you can access the system. We're going to use the monitor because we talked about the monitor before, and I'll show you exactly what this device can monitor. So I'm going to go over to the monitor button here, and you can see the monitor button lights up here. Well, the first setting here is control temperature setting. It's at 69 degrees. We're in a controlled environment. Now, in order to go through the menu, you can go up or down. I'm going to hit the down button. The next menu is temperature 1 temperature, which is the same, 69. That's what the RTD is reading right now. Let's go down again. Is low load, load, and which is nothing right now because the heat trace is not on yet. You're going to go down to resistance, The next function is any ground fault, and that says 0, and that's a good sign. Voltage is next. This is set up for 120 volt right now, so you're reading 124 volts, so it can monitor that voltage. And then the power output is 0 right now because the heat trace is not on. Then you also can test the heat trace, display tests for this device here, and then any maintenance maintenance data. And then that's the end of the menu. Now, if you want to get out of this menu, you always hit the back key out of any menu that you try to get out of. Now let's do this. Let's cut the heat trace on. Over here, you have the status bar, which you may not be able to see, but it's a light for an alarm and it's a light for output. When the output light is on, that means the heat trace is on. When the alarm is on, of course, you have an alarm. We'll talk about how to activate the alarm system and how to clear it later on. But let's go into the set points and let's cut the heat trace on. You can manually cut the heat trace on by going to Shift and the Enter button, which is the configure button up top. You press that, the first menu you have is set point. Right now, the set point is set at 51 degrees, but the temperature is 60 plus degrees. So in order to cut this on manually, what I'm going to have to do is raise the set point and change it. So you do that by hitting Enter again. Now you see the blinking light, and that will allow us to change the set point. So I'm going to raise this up to, let's go to 75 degrees Fahrenheit. Now you notice that the heat trace is not on yet, and this is still blinking. Well, in order to set this, you have to hit Enter. And when I hit Enter, the output light comes on because the set point is now raised to 75 degrees, so the heat trace is working. And I don't know if we can pan over to the light of the end seal, but I have this connected over to the light, and you can see the light on the end seal is turned on now, and that indicates that the heat trace is working correctly. Now, as we come back to the controller, we can back out of this menu if we want to keep the set point at the same set point, and you do that by hitting the back button. And now you're out of the system and the heat trace is on and it's working correctly. The output light is on. Now let's lower this. You go to Shift, Configure, once again, temperature set point. You're going to hit Enter again. It's blinking, so I'm going to go all the way down to 51 degrees again. It's still blinking, it's still on. You have to hit Enter. Now the heat trace is off again. 51 degrees Fahrenheit set point. Now the system is off. Now I'm still in the configure system because the light is on above it. Now let's scroll down and see what else is in this in the menus here. We have low temperature load, which is set right now at 10 degrees Fahrenheit. That's if you want to alarm if the temperature gets below a certain temperature here. You have the high GFI set point here. What this is this is set at 20 milliamps. So this will give you an alarm if you're reading a slight leakage of current. It's 20 milliamps, and it'll alarm. It will not shut the heat trace off as a ground fault, but it will alarm. Now the next feature down is the actual GFI trip feature, which is at 30 milliamp. Now at 30 milliamps, this is set to trip, so this will cut the heat trace off, and that's the ground fault trip. In order to clear this, and I'll talk about this a little later, you have to fix the ground fault before this will clear, but I'll talk about that when I talk about alarms. Going further down, you have feature mode, which currently I'm in the advanced mode, feature mode. You have an advanced and you have a basic. The basic is basically the items that I just showed you before. But getting into the advanced, if you do that, you will get into changing temperature alarms, and you can change many different temperature alarms. You can change some other alarms. You can change, you can go in a point setup, which I like to do, and I go down to, you can switch the control mode. Remember before I told you about deadband and proportional mode, so you can change that in this function here. You can continue to go down. The deadband is at 5 degrees, like I mentioned before. You can change the temperature fill mode, but what I'm going to do is go down to the auto cycle. Now, one of the other features that this has is an auto cycle. You can test this. You can set the test either at 8 hours. Every 8 hours, this will test itself to make sure the heat trace is working. Usually what I like to do is go down, and I like to set it at 24 hours. And that's what the interval is. You would change it here. Right now it's set at 8, but you could change it to 24. So then, if I back out of this, I'm back in point setups here. I'm going to go down. You have miscellaneous setups, communications, and then that's the end of the menu. At any time, what you may use is just the first basic sets. Anytime you get below that, you may want to call either myself or technical support, because it gets a little tricky and you don't want to mess up some of the programming here. So that's essentially the program itself. Next, what we'll do is talk about the alarm and how to clear alarms. Okay, so now we've learned about how to change the set points within this 910 controller. Now what we're going to do is we're going to go over an alarm. I'm going to purposely set this into an alarm, and then I'm going to see if I can clear it. So what I'm going to do is go to Shift, and this particular alarm setting that I'm going to set is the low temperature alarm. So what I can do is go into the programming, and I'm going to go down to low temperature. Right now I have it at 28 degrees. I entered the function by hitting enter again, or hitting the mode. I'm going to go all the way up to, since it's a little warm in the room, I'm going to go up to, let's say, 75 degrees again for the low temperature. And I've already set the low temperature alarm. Now it's at 75 degrees. It's still blinking, so I'm going to hit enter and see what happens. Okay, now you can see the alarm light just popped on and it's flashing. The reason for this is because I set the low temperature alarm at 75 degrees and the room temperature is only 60 plus degrees. Now, in order to try to clear this alarm, what I'll do is I'll go over to Shift. Well, let me hit back first to get out of the program. And when you see an alarm, if you come across this, you'll have to hit Shift and then the next button over, which is the alarm button, or it says test on there. And this display now reads exactly what the alarm is. Now you can go up and down this menu to see all of the alarms that may be on the system right now. So right now we have a low temperature alarm, and then if I hit down, you see N there, so that means it's no more alarms. Now generally what I would do in order to try to clear an alarm is I would go to enter and hit enter. It says low temperature alarm 1. You hit enter again and it asks you if you want to reset this, and then yes. So yes, I want to reset it, so I'm going to hit enter again. It says no alarms, right? But it popped back on again. The reason for this is because I did not clear the alarm first. So a lot of these alarms that you get on the controller, you're going to have to clear first. If it was a ground fault alarm or this low temperature alarm, the low temperature alarm, it has to reach the temperature in order to get that. So what I'm going to do is clear the alarm. I'm going to go back. I'm going to hit Shift again. I'm going to hit enter. I'm going to go down to low temperature. I'm going to access that, and I'm going to go down all the way down to 45 degrees. And I'm going to hit enter and then back. Right now I'm out of the system as far as programming. The alarm is still flashing. The reason why is because now I have to go into the alarm menu and clear it. So you hit shift, alarm, and then you have this reading, low temperature. You're going to hit enter and it's going to ask you to reset. It says yes, no alarms. It reads now. Now I can back out of the system and it's all cleared and ready to go again. So anytime you don't have an alarm, like I said before, you're going to have to clear it first. Now for troubleshooting, if it says a low temperature alarm, make sure, or no temperature reading, you want to make sure that these wires for the RTD is connected. If it gives you a low heat trace alarm or low power alarm, what you want to do is make sure you check the heat trace circuit to make sure that the heat trace is working correctly. If you get a GFI or a ground fault alarm, you're going to have to check the heat trace from the power connection box. From the power connection box. And essentially, that's how you clear an alarm. It's pretty straightforward. Like I said before, I'm going to leave my contact information and also Pentair Thermal Management's contact information later on in this video. And if you have any questions, you can always ask us. You also have been provided an installation instruction manual, which will be very helpful in troubleshooting any problem that you may have of the 910 controller. Here at the Dell Prentice Company and Pentair Thermal Management, safety is a high priority. We're about to go over some safety procedures that you should follow anytime you're activating the heat trace panel. Okay, now we're going to talk about safety. Of course, you always want to cut the breaker off anytime you want to touch any components inside this controller. Okay, so we did just that here. We also have, and I'll show you a little later, but we have knockout holes on the side of this controller that you could put a little lock on it if you're concerned about people tampering with this controller. So you'll be able to do that as well. Now, as I said before, you have a protective cover here, which you have two Phillip head screws on each side. I loosened those up to talk about this and show you the inside again. As you can see inside the controller, these components are all low voltage, so it's not really a big hazard for shock here. The only hazard for shock would be these terminals here, which are the line voltage and the output voltage here. And the only way you really be able to get to those is if you actually stuck something inside those terminals here. Of course, I mentioned many times before, this also has a safety mechanism as far as ground fault protection, and this is equipment protection ground fault. And this enclosure is rated for a class 1 Div 2 area as well. And pretty much that's all the safety features this unit right here has. So in conclusion, what you learned today was what self-regulating cable is and how it works. You also learned about the different components involved with a heat trace system. You also learned about the 910 controller, the features, how to change the set points, and also how to clear the alarms. And then finally you learned about safety and what procedures you need to follow. At this time, usually I would ask for questions, but obviously I can't do that. So what I'll do is I'll put my contact information on the bottom of the screen, And then I will put also the contact information of Pentair Thermal Management's technical support. Anytime you need an answer, you can either email or call us at any time, and we'll respond to you. I want to be the first again to congratulate you on your new purchase. And I want to say thank you for your purchase. This is Dshawn Grigsby from the Dell Prentice Company. I want you to be safe and have a great day.